Hello, today we're going to run a simple simulation in Star CCM in order to demonstrate how far away far field boundaries have to be so that they don't affect your solution. Again, and this is an introduction to Star CCM essentially from the very beginning. So what we're going to start is you're going to launch Star CCM. This depends, you might have a desktop icon, you can double click on that. I'm just going to click on it through the menu options. So I'm going to load Star CCM. All right, now that the Star CCM is loaded, what you want to do is you want to essentially load into your Power on Demand license. So we can go to File, New Simulation. You should note that right down here, there's a server idle time limit. You should have set this to 0.5. Mine's 0.1. That's not really a problem, but essentially, because Power on Demand licenses are used um, um, by the hour, even if it's running in the background and you're not running any program, you will be taking up hours. So please make sure that you have a server idle time limit so that it logs out and you don't leave it running all night. Even though you're not doing anything, it'll still use up the hours. So anyways, we're going to get started. The first thing we want to do is create our geometry. It should be noted that Star CCM is technically a 3D mesher and solver, and so therefore the first thing we need to do is make a 3D geometry, and then we're going to convert it into a 2D geometry for our simulation. So the first thing to do is you can click on the geometry and click on the 3D CAD models, then you right click and you say new, and it's going to bring up the 3D CAD model macro. All right, so now that the 3D CAD macro has been loaded, you can see by just clicking and moving and twisting around, you can see that you have the different planes. We're going to create our plane our sketch in the XY plane. So we click on the XY plane and then right click and create sketch. All right, so you can zoom in this using your middle mouse, scrolling on your middle mouse. You can see that essentially there's this grid here. This grid can be set to different sizes. For instance, over here, if you say set grid spacing, sketch grid spacing, the grid spacing is right now is 0.01 meters. We're going to leave that as the default, but if you wanted to be that as larger or smaller, you could adjust it if needed. Furthermore, you can adjust the snap to grid, and so essentially the difference is when you're clicking, let's say you're trying to add a point, whether or not it snaps to the grid or whether or not you can try and put it anywhere and it doesn't snap. So we're not going to do that right now. We're going to keep it as snap to grid because we're going to keep everything the same. So what we're going to do, this geometry is going to be slightly different than what you have to do in class. But so the first thing you want to do is create a circle. So in the center, you want to have it essentially the center of it at the origin, and you click, and then you click out. We want its radius, in this case, to be 0.1. This is not necessarily the same as what you'll be doing. So the radius is 0.1, and so you click right here. Now, it should be noted that this can actually still be drug around. So I can actually drag this point from here to here, and I can actually change the diameter of this radius. So what we actually have to do is have to actually dimension them. So if we click on this point and you see that the point values are 0, 0, and that's what we want. So if you right click on it then and apply fixation constraint, you now cannot move that point. And furthermore, this radius, if you click on it on the line and then right click, you can apply a radius dimension, and we wanted that to be 0.1, and so you can type that in and hit OK. Click on OK. All right, so you have to add a rectangle around that as well. So we can use this create rectangle tool. So we click on that, click on one corner, click on the other corner. And again, this is definitely not the size we want, but we want it to be a square. So the first thing we want to do is essentially make sure that these two sides are equal in length to each other. So in order to do that, what you can do is you can click on this one, holding Control, click on this line, and then still holding Control, right click, and apply a constraint. And so the constraint that we want to apply is the equal length constraint. And so now that these two are equal lengths, and since it's a rectangle, these are equal lengths, and these are equal lengths, so all the sides are equal length. We also want to adjust essentially the distance from here to here. We want to change the S value. Unfortunately, since there's not a point right here, we're not going to be able to dimension from here to here, but we can dimension from the origin to here. So in order to set that, what we can do again is click on the origin while holding control, left click on this line, and then still holding control, right click on the line again, and we want to apply a distance dimension. So in the case that I'm running right now, I'm going to run an S over D value of 3. This means that S, which is the distance from here to here, is 0.6. Since the radius is 0.1, your S over D, your distance from here to here, should be 0.7. Again, that's some math that you're going to have to do depending on the geometry that you require. Also, I'm going to click Expose Parameter, and I'm going to get to why we do that in a little bit, but essentially this enables us to use this value in other calculations, and it also allows us to edit this without coming back into the macro each time. So when we go into the main menu when we're running Star CCM, we can change this parameter instead of loading it each time. So we click OK, and it moved it all the way. If we zoom out, we can see it moved it all the way over here. If you click and drag these walls, since there's been no constraints about them, you can actually move them around, which is fine. But essentially what we want to do is we want to set this dimension, the distance from here to here, essentially equal to the same distance. So again, if we click on the midpoint, on the origin, and holding control, click on the upper line, and then still holding control, right click. We want to apply a distance dimension, and we want this distance to be the same distance as this distance here. So in order to do that, what you can actually do is you can type in $, distance, and this essentially will reference that distance and make it exactly the same. So we click OK, and it's centered right there. So now we essentially have set those up fine. So now what we need to do is essentially we need to change these dimensions because we didn't really say how long or far these were. So what we need to do is define this distance right here, this length of this line. So if we click on it and then right click and apply a length dimension, so we click on that, we want this to be essentially twice the distance because we want it to be essentially distance from here to here and distance from here to here. And since there's an equal length constraint, that will essentially follow through for the rest of our geometry. So what we can do for that is you can type in $distance times 2. Again, you can actually type in any sort of mathematical equation referencing the variables of which you've named here. So we don't need to expose the parameter because we only essentially need to change the distance, and then everything else will change according to it. So we click OK. It really kind of went crazy there. Hopefully yours doesn't do that. However, you can see that it's changed by zooming in and out. It's centered. These are all equal lengths. This is essentially the circles in the center, and so our geometry sketch is done. So we can click OK. And what we want to do now is create a small extrusion. So what you can do is if you click on sketch and then right click on it, you can click extrude, and some options will come up. You can essentially change the direction that you extrude, the type of extrusion. In this case, we're just going to make a slight extrusion in one direction. We're going to call that essentially 0.05 meters, and click OK, and it'll create that for us, and you can see that there's just a slight extrusion like that. And that's essentially the 3D model that we're going to use as a basis for our 2D model. So at this point, we can close the 3D CAD, and you will now see that there's a little plus next to this 3D CAD model. If you click on it, what you can see essentially is, if you open it up furthermore, there's a body, and that's the body that we just created. Furthermore, there's these design parameters, which is essentially what we exposed, and you can see distance. And down here in the properties menu, you can click it and change this value, and it would change it for you. And we'll get to that near the end. However, just so you know, if this properties window is not here, if you click on window and click on properties, that you can make the properties window appear. So if this is not here for you, you're going to want to go to Windows, Properties. All right, so next what you have to do is you actually have to right click on this body, and you have to create it as a new part. So we collect new part. There's a bunch of options here, so some tolerances, some sharp angle edges, but we don't really need to change any of these right now. We're good, so we can just click OK. All right, now that it is essentially, you can see that there's a new part here. So if we click here and click here again, and we're going to open up the surfaces, you'll see that there's only one surface. So let me show you by essentially visualizing this. I'll talk about what's going on. So in order to do that, though, you need to create a new scene in Star CCM. In order to create a new scene, what you can do is you can come up here and click on this button. It says Create or Open Scenes. Then come down and click on Geometry, and it'll create a new scene for you. And you can see that it's just your geometry. And as you can see, there's surfaces, so they called all your surfaces one surface default. So that surface, all these sides are just one surface and they're connected. So we don't want that. So what we want to essentially be able to label them as different things. So in order to fix that, what you can do is you can right click on it, and there are different ways to split them. The easiest way, since everything's at a 90-degree angle, is to just click on Split by Angle. And essentially this angle that you see down here says 89. So anything greater than 89, it'll split into a new surface. Additionally, you can select the body. Right here, this blue marker indicates that is what has been selected. So we click OK. And you will see that there's a bunch of now different defaults. You have all of these different surfaces. So we're going to rename them. This one right here, we're going to call it Inlet. So if we right click on it, then click down at Rename, you can type in Inlet. It should be, you should hit Enter afterwards. Sometimes if you click somewhere else, it won't save your changes. So this back here, essentially this is in the Z equals 0 plane. So if you right click on it and rename it, we're just going to call this body 1. Hit enter, and we're going to name them. This is the top plane, so we're just going to call this, we'll call it body 2. It's not going to be used in our mesh, in our simulation, but we will name it just in case. So hit enter. Down here we will rename as a symmetry plane, so we'll call it a symmetry bottom, and this will rename as the symmetry top. So again, we're clicking on it, we're right clicking on it, then clicking on rename, typing in symmetry top, enter. We're going to call this the cylinder, and this we will call the outlet. All right, now that we've renamed all those surfaces, what we want to do is we need to essentially create this into a 2D geometry and mesh. So if you right click on body, you can go to mesh operation, go to mesh, and you want to create a badge for 2D meshing. So if you click on badge to 2D meshing, again, you're selecting body 1, which is what that blue dot, blue square indicates, and it's going to create an operation. So if you wanted to have it done immediately after clicking OK, you could click this button. We're not going to do that just in case you didn't click it, so we're going to click OK. And you'll see right down here, there's an operation. and the operation says badge for 2D meshing. There's a little explanation point next to it, which means it hasn't been executed or it needs to be updated. So what we can do is right click on it and execute. And you will see now that essentially the icons in front of all of your surfaces have changed. This essentially red, filled in red indicates that that is your main surface, and all so this red outline indicates that it's all the boundaries on that surface. And this other one, body 2, you see hasn't really changed. It's just a simple surface. It has not essentially been included in the badge for 2D meshing, because what the badge for 2D meshing does is includes anything in the z = 0 plane, and the body 2 surface, if you remember, was not in that plane. So now what we want to do is we need to create a region. So in order to create a region, what you can do is you can right click on this and you can assign the parts to region. We want to create a boundary for each part surface. The default right here, if you can see, is create a boundary for each part, which would essentially be undoing everything that we just did. So we want to click on it and click create a boundary for each part surface. That way that all of these surfaces that we have defined essentially are called a boundary. So we click OK, and apply, and we can hit close. And if you see down here in regions, there's a region that was new created. We can expand it a little bit more, and you will see that there is a bunch of different surfaces for the body 1, but there's not body 2 isn't included, and everything's body 1 dot cylinder, because that's the boundary on body 1, which we called. So what we need to do is we need to mesh this. So going back up to parts, if you click on it, actually you can just right click on it and create a mesh operation. And we want to, instead of a badge for 2D meshing this time, we want to create an automated mesh. So we click on that, and we click, you can choose your different volume meshers. In this case, we're just going to do a simple polygonal mesh. So we click on that. We're not going to add a prism layer because we're going to alter that ourselves. So we click OK. And now you can see right here, there's another operation that pops up. It's called the automated mesh. There's a little explanation point for it. So it's not going to mesh. It hasn't meshed yet, but it will mesh once we execute it. But first, we're going to change some of these values. So if you click plus, and essentially you can see that it is a polygonal mesher. So that's what we want. Default controls. So if you expand that, the base size is essentially a value that everything else is going to reference. The essential goal is, if we change the base size, then we change everything else, because everything else is going to be a percentage of those values. So right now we're going to change that base size to something really small, because again, our geometry isn't that big. So we're going to change our base size to 0.05. And we're also going to change, so we hit enter. We're going to change the surface growth rate. So essentially this is the rate at which it grows from the surface. We can change that to 1.1. That essentially means that from each surface it grows slower. The larger that is the faster it grows. The smaller, the better off it is. I mean, not the better off. The smaller it is, the slower it grows. So we hit enter again for that. And so what we want to do is we want to add a few custom controls, because we want it to be really, really small around the cylinder, but we want it to expand outwards. So what you can do is if you click on custom controls, right click and say new surface control, and expand that, you will see that there's a new surface control. Down here in the properties menu, you will see that there is no part surface selected. So what we want to do is we want to select one of those. So by clicking that button, expanding this out, we want to essentially add it on the cylinder. So we want to add, so that blue square indicates that we're selecting that. And so we had clicked on it, and then we click OK. And now we're applying essentially a surface control on the cylinder. And so if we expand that further, you will see, and expand it again, you will see that essentially all of these essentially will say that your target surface size is essentially the same as the parent, so that whatever your default controls are is what it is right now. So it's just saying that you added a surface control, yes, but you haven't changed anything about it. So what we want to do is we want to change the target surface size so that it's really small around it. So if we click down here, instead of parent, we call it a custom value. You see down here a plus comes up by the values. So we can change that, and we can click on and expand this and change the target surface size. So if we click on target surface size, we can either make it relative to the base, or we can essentially click on this arrow and change it to an absolute value. In this case, we're actually going to change it to an absolute value just so that it's always the same, and that we can get essentially a good number of divisions. So if you change it to absolute and then click down here on absolute size, the value of the absolute size around they want to make it originally is 0.05. But what we essentially want is we want little dots all the way around here. I'm going to set it so that there's roughly 180 divisions by just doing some math. So if my diameter is 0.2, just find essentially the area on the outside and then divide by 180. In this case, what you end up getting is roughly 0.0034, and we hit enter. It should be noted then, is that the minimum surface size up here for the default control is actually 0.005. So we want to make that smaller because essentially if we essentially said that the minimum size is less than our absolute size on the surface, and so that's going to cause some problems. So we can just adjust this percentage of base. We can call it 5% and hit enter, and you can see that the absolute size for the minimum surface size, again this is under default controls, is less than 0.0034. So you always want to make sure that your minimum surface size in both cases, so here and here, are less than the absolute size that you ever put anywhere else, or else it's not going to work out. The other thing is I don't really have to adjust it here because this minimum surface size is just a function of the parent, which is the default control. So now that we have that, we can minimize some of this, and we can right click on this and execute the mesher. All right, so now that the mesher has executed, you can tell because it says executing operation finished. Additionally, it went through a bunch of, if you scroll down, it went through a bunch of different operations down here. So we don't see a mesh. So in order to see the mesh, what we can do is we can create a new scene for the mesh. So similar to what we did for the geometry, if you click here and click mesh, this is the mesh that you just created. So this looks pretty good. Again, you can adjust the growth rates, adjust the base size, adjust surface. You can adjust all sorts of things to get a good mesh. In this case, it looks pretty good for us, so we're going to just keep that. So what we're going to do then is, what we need to do is we need to essentially run this and set up some boundary conditions. So if we can minimize out of the parts and minimize out of the geometry because we're basically done with that right now. So what we need to do is we need to modify the physics continua. So if you expand this continua, and physics 1 will show up. And so if you right click on this, select models. So we want a essentially enabled model. It automatically selects recommended models. It knows it's a two-dimensional model, so it selected that already. We want steady. We also want it needs to be liquid. We're going to click on segregated flow, and then laminar once it pops up. So the viscous regime right here is laminar. The equation of state, just it's a constant density liquid. And there's a bunch of other options you can change, but we're not going to use any of those right now. So we can click close. All right, so now under physics, you see that a bunch of options have come up. So if we expand these models, you can see that it's constant density, it's a liquid. It essentially automatically assigns it to liquid as H2O with certain material properties. We don't want to use those values. We want to use our own values. So what we can do is you can actually right click on this, and we can rename it as your other fluid. So we're just going to call it fluid. Hit enter, and the density is a constant. If you expand that, the density we only want as 1 kilogram per meter cubed. So we hit enter, and the dynamic viscosity, if we expand that, we want that essentially 0.001. Again, this is a completely fictitious fluid. You can alter these to whatever you want. This is just a really, really fictitious fluid to get the Reynolds number that we want. So now that we have set those values, again, it's two-dimensional study. This is where you would change some. For instance, if you had multi-phase, you would change the different fluid properties. But right now, we're just running a simple one, so that's all we really need to set up right now. So we can minimize some of that just so it's not in our way. We also need to set up these boundaries. So the cylinder, if you click on it, you can see down here in the properties window, it's a wall, which is what we want. The body 1 inlet starts out as a wall. We don't want it a wall. We want it to be a velocity inlet. And so if you expand now with the velocity inlet and expand the physics values and the physics conditions, you can essentially change whether how you essentially are specifying the velocity by changing the magnitude and direction, adding the components. We just want it essentially the velocity just into the boundary, normal to it, at a constant velocity. So we want it at a value. In order for a Reynolds number of 2, essentially that means that the velocity has to be 0.01, because, again, our diameter was 0.2. This is going to be slightly different for you if you're running the simulation for an ME 521 course. So we hit enter. And so that's it for the inlet. For the outlet, if we click on it, again, it sets it as a wall. If you click on it, on that and that arrow, and select pressure outlet, and for the symmetry bottom, we want that to be a symmetry plane. Same with the top. So we click and select symmetry plane. All right, so that's how that's set up. So what we need to do is we need to determine how to run it. So if we subtract out of that, minimize out of that. So if we minimize out of that by clicking that, so now we need to essentially set our conditions for. Now we need to set our conditions for convergence. So essentially, if you click here and you can expand for essentially different types of the solver, there's some under relaxation factors, some values you can change. We're not going to change any of that right now. We're just going to keep it exactly as it is. So we're just going to keep that as it is, and so we can minimize that. And so the stopping criteria, if you expand that, essentially maximum steps. So we're going to change those maximum steps to some large number, so it just keeps running until it reaches the convergence criteria that we specify. We can also right click on this and create a new criterion from monitor. And so what we want is for the continuity, we can click OK. And the continuity minimum limit is essentially the minimum value of continuity before we essentially declare convergence. So we can click make this 10 to the negative eighth. Again, you can change this. So we also are going to add criterion for the x momentum as well as the y momentum. So we'll do that one at a time. So the minimum limit, 1 to negative 10th, eighth. And the same thing for the y momentum. All right, so after we've set up the x and y momentum as well as the continuity, we can minimize those. And we're ready to try running this. So what we can do is, if you wanted to run just one step, you could run it here. But we're just going to run from essentially the entire thing. So we can click run. And a residual plot will pop up. Yours should not be this glitchy. However, my computer apparently is having trouble this morning. Okay, so it stopped, and I forgot to change this is an important lesson because I forgot to change the continuity criterion for the logical rule as and. So for all of these have to be and, or else it will just stop at the first one that it meets. So we can continue running. All right, so now you can see that it says stopping criteria, continuity criterion, x momentum, and y momentum have been satisfied. Again, that's because you have to change the and, essentially this value to and. And again, if you want to keep running, you can just run after that point and it'll pick up where you left off. So anyways, so now that it's run, what we can do is we can take a look at some things. So we can subtract out of that. And so we want to create a new scene. So if we want to create a scalar scene, and if you click down here for scenes, this scalar scene doesn't really have any selected right now. But what we can do is we can open this, displayers, for the scalar. You can adjust all sorts of viewing options. You can select all sorts of viewing options, but if you expand it down to scalar 1, you can expand parts. You will see a scalar field, and so that's essentially what we want to set it at, what we want to see. So right down here, you'll see select function. If you click next to that, those 3 lines, we want to see, for instance, let's say we want to see the velocity contour. So we can scroll all the way down. There's all sorts of options. We can expand velocity, the velocity magnitude contours. Click OK, and it applies it. And so essentially this is the velocity contours. Again, you can change all sorts of values here by adjusting some of these. The minimum, the maximum. You can adjust the units. You can change auto range. So you can do all sorts of stuff to make this look prettier if you want, but this is what it essentially how you display the velocity magnitude. Again, if you wanted to just then create a new scalar scene, so if you wanted to rename this scalar scene, you can right click on it and rename it, and we can call this velocity. So again, essentially up here there's all these scenes. But if you for some reason exit out of velocity and you wanted to reopen that, what you can do is right click on velocity and just click open, and it'll open it for you. So we want to create a new scene, right? Because we want to create some pressure contours. So you can either right click on this and create a new scene, or we can do what we've been doing before and just clicking this button up here and clicking a new scalar scene. Again, it's called Scalar Scene 1. We can do the same exact thing, except this time for pressure. So we can go to displayers, down to scalar. The scalar field that we want to select is the pressure. And again, this blue dot indicates it's being selected. Click OK. So there's the pressure. And we can right click on this and rename it as pressure and hit enter. So now we have those different scenes that we can essentially go from. So we can view the velocity arrows by essentially creating a new vector scene. So if we click on here and click a new vector scene, it actually will automatically assume that they're arrows. And we can adjust those in the same way, essentially, that we did the scalar scenes. So if we wanted to do something else, we could click on it, change the vectors field from velocity to something else. We're just going to, like, for instance, if you wanted vorticity or shear stress or something, we're just going to keep that as it is. All right, in order to view the screen lines, what you have to do is you have to actually go up to derived parts up here under regions. You right click, your new part, and you want to create a streamline. So for the streamlines, what you want to do is essentially you want to select where it starts from. So you can change this to Inlet. Click OK. The resolution, you want these to be higher. So let's just make these 50. And click create. So now if you hit close, essentially you'll see that they have popped up. Alright, so after you have, essentially you want to create a new streamline, and so this is what you're going to come up with. So this is kind of crowded because it's already on a different scene. So what you can do is you can actually right click here, create a new scene, new geometry scene, and so it's just a blank surface. And then if you actually click on streamline, you will see how all the streamlines just come across now. So yeah, so this is what you can see for the streamlines. That's that for that. Now, one last thing we want to do is we want to find out what the force on the cylinder is. So if we go on reports, we right click, new report. We want essentially the force. And we want the force, if you right click on it, edit, essentially the direction we want the force on is in the X direction, which is what we have, and we want the force, so we click close. The part that we want the force on right here, if you click down here, is we want it on the cylinder, so we click OK, and then we can run the report, and down at the bottom it will tell you what the monitor value of that force is. So you would then run this for different far field conditions. So in order to do that, essentially the easiest way to change all this is, if you recall, if you get the geometry back up, we defined the 3D CAD model with certain design parameters. So if we change this value, so we want to change it to, let's say we want an S over D of 6 now. This means if the diameter is 0.2, S over D means that S is 1.2, and so the distance, which is essentially from the origin to the wall, is 1.3. So that's just math that you're going to have to do depending on your geometry. If you hit enter, you'll see that an exclamation point comes up next to it. So we right click on it, update. We also need to update this. So if we expand parts, right click, update that. We will also need to update these two operations, so you can execute both of them by right-clicking Execute. Meshing may take a little bit of time. You will see now, if we actually go over and click on the meshing, this is our new mesh. You will notice that this is roughly the same expansion. And so then what we can do, that's all we can do. Nothing else is going to be changed. So then we can run the simulation, and you would then essentially you can see it jump back up, and it's going to go all the way down and solve again. So we're going to stop that right now. You can stop it at any time by clicking the stop iterating and hit run. At which point you can then update any of these scenes. So for instance, this pressure scene, it actually automatically is updating for you, but if it's not, you can right click and refresh or apply the representation of the latest. Sometimes it does, sometimes it doesn't. So that's all you would do. You would then just go through, update that, and you could essentially change the distance for any S over D you want. Make sure you update the CAD model, update the part, update these two operations, and then it should have remeshed for you, and you can just run it over and over and over again. Run the report each time by right-clicking Run Report to find the forces, and you can also view the pressures, the vector scenes, and the velocities. And so that's about it. If there's any questions, please let me know in the comments. And I wish you the best of luck. Thank you, and have a good day. One final thing before I actually... One final thing, sorry. So if you wanted to save this data, you can go to File, Save As, and you would want to save it as somewhere with a name that you... we're going to save this in My Documents. You can save it, and it saves as a sim file, and you can click Save. You probably should have done that earlier, but just that's how you save it. Thank you. Sorry. Have a good day.